what is remaining for us in this section is, I think, some parts from here. I'm not sure that with you we finished circles or not, so we will go over it quickly. And this is the main part that we will study today, inshallah, before having the quiz number 3. So you should be able to do graphing equations after finishing this section, find the intercepts and find the equations of circles, graph circles, and determine the symmetry properties. Let's go over what we did quickly. The graph of equation, what we mean by graph of any equation in X and Y, it is all the points in the plane that satisfy the equation, that make the equation true. If you want to sketch the graph of any equation, plot points, use points, select some values for X, find values of Y, plot these points in the XY plane, you will have the graph. The intercepts, if you want to find the X-intercept, put Y equal to 0 and solve for X. If you want to find the Y-intercept, put X equals 0 and solve it for Y. We did that in the previous class. Also in the previous class, we have introduced to you the standard form of the equation of a circle. If you have a circle centered at H and K with radius equals to R, this is its equation. And if you have equation like this, it will be equation of a circle with center H and K and radius R. If the center is at the origin, it will be X squared plus Y squared equals to R squared. I think we did solve this with you in the previous class. The first one is direct, just direct substitution. You have R, you have H, you have K, substitute. In the second part, you have the diameter, and the diameter, of course, it is the line that is passing through the center and with end points on the circle. The center point, how to find the center? It is the midpoint. How to find the radius? It is the distance from the center to that point. When we have a circle tangent to the x-axis, did we explain this in the previous class? So if you have a circle that is tangent to the x-axis, then its radius will be equals to the absolute value of the x coordinate, the y coordinate of the center. If it is tangent to the y-axis, R will be, there is a missing the here. The x-axis, the y-axis, the origin, these are, shabab, you should use the with them because they are only 1 and 1. There is no another x-axis. It is like the moon, the sun. If it is tangent to both, of course, in this case, H will be positive or negative K, and R will be equals to the absolute value of them. This is an example. The center radius form, it means the standard form. Find the center radius form of the equation with center 3 and 2, and it is tangent to the x-axis. Because it is tangent to the x-axis, it means that R is equal to what? R will be the absolute value of K. What is K in our case? 2. So R is 2. So now you have H, you have K, you have R, you have the standard form. If you expand the standard form, you will get what is called the general form. In the general form, you cannot know what is the center, what is the radius immediately or clearly. So you need to write it in the standard form. How to go from the general form to the standard form? You need to complete the square. To complete the square, it means you should have a perfect square. Look, this is not a perfect square. If we add the square of the half of the coefficient of x, which is 9, it will become a perfect square, which is x minus 3 all squared. To maintain the equality, you need to add the same number to each side of the equation. I believe that we also studied this example with you. What you will do kind of a grouping. You will combine the x terms together and the y terms together. Then you will ask yourself, what is the coefficient of x?
2.
What is the half of 2? 1. Square it.
1.
So you will add 1 for both sides. Similarly, the coefficient of y here is negative 6 divided by 2, negative 3. Square it, 9. Add 9 for both sides. Now what you have here is a perfect square. What you have here is a perfect square, which is x plus 1 all squared plus y minus. This is now the standard form. From here, you can know what is compare it with the standard form. If you compare it with the standard form, you can easily realize that h is what? -1. And y is what? Sorry, k is what? K is 3, and r is what? The square root of 3, because what is there is r squared. The last part of this section is about symmetry. What is the symmetry and how to test it? If you need to know what we mean by symmetry, look at this graph here. This is the x-axis. Consider that you have a mirror. We have a mirror here at the x-axis. Notice that this part, look, the upper part here, it is just the same as this, but reflected in the x-axis. It is like the image of this one. So the graph is unchanged when reflected about the x-axis. So when you reflect this on the x-axis, it is the same, but just with a reflection. In other words, if the point x and y, if you take a point here, x and y, the point that is x and -y will be also on the graph. So both points, this point and this point, both of them are on the graph. If they are both on the graph, then this graph is symmetric about the x-axis. Let me repeat that. If you replace y by -y, you still have the same equation. You're still on the graph. So this kind of symmetry is called symmetric with respect to the x-axis or about the x-axis. How to test it, how to know it? If you want to know or to check that a graph or an equation is symmetric about the x-axis, just replace y by what? If the resulting equation is equivalent to the original one, then it is symmetric. If it is not equivalent, it is not. Similarly for y. Look here, if you have a mirror at y-axis, this part from the graph is the same as this, but just reflected on the y-axis. In other words, if the point x and y, it is on the graph, also the point when you replace x by -x, it will be also on the graph. It satisfies the equation. You will get the same equation. How to test the symmetry with respect to the y-axis? Replace y by negative, but replace x by negative x. This means to right and the left of the y-axis. There is a third type of symmetry, which is symmetric, the symmetry with respect to the origin or about the origin. In fact, it is equivalent to the symmetric about this line. Imagine that you have a mirror here. The mirror is here, which is the line, by the way, y equals -x. Notice here that this part from the graph is a reflection on this. It is the same of this, but reflected about the origin or with respect to the origin. How to test the symmetry about the origin? If the point x and y is on the graph, the point also -x and -y should be on. And this can be easily memorized, Shabab. Here you are in the first quadrant, x and y. In the third, it will be what? Negative, -x, -y. Let's take an example about that. X equals y squared. How to test the symmetry with respect to the x-axis? If you want to see if it is symmetric about the x-axis or not, what you will do? You will replace y by -y. We can agree about this means that we will replace y by -y. So you will take y and write -y instead of what you will get. You will get x equals to -y. -y to the power 2 is what? Y squared. Here it is. X equals to y squared. Now, if you want to, what we conclude from this? The same equation, not only equivalent, it is exactly the same. It is equivalent to the original one. So the graph is symmetric about what? About the x-axis. Now, if you want to study or to determine or test the symmetry with respect to the y-axis, what you will do? You will replace x by -x. What you will get?
I get -x equal y squared.
If you replace x by -x, you will get -x equals to y squared. Is it equivalent to the original one?
No.
You can do more to know if it is symmetric or not. Multiply both sides by -1. If you multiply both sides by -1, what you will get?
Negative y
X
squared.
equals to -y squared.
Yes.
It is still not equivalent. Now, what do you think about the third symmetry? We have also now a symmetry about the origin. Can we conclude anything about it? Can we say that it is not, or according to what we have here? We have here that is symmetric about the x-axis, not symmetric about the y-axis. So what? It will not be symmetric about the origin. Why? I will explain that for you at the end because we have a conclusion about that. But we can check that. Let's check that, Shabab. What we will do? We will replace x and y both at the same time by -x and -y. Let's go, and this is the original equation. X equals to y squared. Replace x by -x and y by -y. What you will get? -x equals to what? Y squared. If you multiply both sides by -1, it is not equivalent. So both of them are not equivalent to the original one. So as expected, it is not. And we will see that, Shabab, with many examples. If it is symmetric with respect to x-axis, but not with respect to the y-axis, it will not be symmetric with respect to the origin. If it is symmetric with respect to the x-axis and the y-axis, it will be symmetric with respect to the origin. If it is not symmetric with both, with x-axis, with x-axis and the y-axis, it might be not symmetric with respect to the origin. This is the graph of this equation. As I said, we are not interested in the graph of this type of equations at this moment. Now, test this equation for symmetry about the origin. He asked about that. He wants you to test it for the origins. What you will do? You will replace y by negative and x by -x. What will happen? It will be -y equals to what? -x to the power 3 plus 9. Is it equivalent to the original one? Not yet. If you want to make sure, multiply both sides. What is this? Is the meaning of equivalent equation. When you multiply both sides or divide both sides or add or subtract the same numbers, you have equivalent equations. So this will be x cubed minus 9x. So it is equivalent. So it is symmetric about what? What we conclude about the symmetry about x-axis and y-axis? No. Who said? Nothing. We conclude nothing about it. Now, what you want? So it is symmetric about the origin. What you, if you want to check for the x-axis, let's say, the symmetry about the x-axis, what you will do? You will replace y by -y. What will happen? What you will get? It will be -y equals to x cubed minus 9x, which is clearly what? Clearly not. It is not equivalent to the original equation, even if you multiply by -1 or you didn't. So it is not equivalent with respect to what? So here we will say that it is what? Not. So it is symmetric with respect to the origin, but not symmetric with respect to the y-axis. What you will conclude about the y-axis? It will be not symmetric. It cannot be, because if it is symmetric about the origin and symmetric about the y-axis, it will be symmetric about the y-axis. Yes. Let's take another example. What is the graph that is symmetric about all? What is this?
Circle.
Only circle? Circle centered at the origin with radius equals to what?
2.
Any circle centered at the origin, it will be symmetric about the x-axis, the y-axis, and the origin. Look, if you replace x by -x and y by -y, they will stay the same and change. What about if you have a circle that is not centered at the origin? It will not be symmetric about. Of course, you need to check. It might be drawing on the x-axis. For example, this is a circle. It will be symmetric about the x-axis. Okay. So if it is on the, if the center is on the x-axis, it will be symmetric about the x-axis, and so on. So it depends on the situation that you have. But in general, all the circles centered at the origin are symmetric with the three, with respect to the three symmetries. We have here special offers. This is the conclusion. Of course, if you solve many examples and you will conclude this. The proof also is easy, but we are not interested in that at this level of the course. A graph symmetric with respect to both the x-axis and the y-axis is automatically what? Symmetric with respect to the origin. Be careful about two. A graph that is symmetric with respect to the origin is not necessarily symmetric with respect to what? To the x-axis or the y-axis. So if it is symmetric with respect to the x-axis and the y-axis, it is symmetric with respect to the origin. But if it is symmetric with respect to the origin, it might be not symmetric with both of them. This is the best offer that you have here. Buy two and take the third for free. Of three types of symmetry with respect to the x-axis, y-axis, and the origin, a graph possessing any two must have the third one. So if it is symmetric with respect to the x-axis and the origin, it will be symmetric with respect to y-axis, and so on. I think you are ready now to practice, Shabab. Please, in your notes, tell me or discuss the symmetry of the following equation. One by one. If you finish A, go to B. If you finish B, go to C. And tell me which one is symmetric with respect to who? With respect to what? During that, I will take the attendance and pause the recording. We still have 10 minutes to start the quiz. A is symmetric with respect to what? The origin. You're right. It is symmetric with respect to the origin. How? So what you should do if you want to test such equations, you need to start testing the x-axis. How to test the x-axis with respect to the x-axis? You will do what? You will replace y by negative y. So it will be what? X squared equals to the absolute value of x minus y, which is what? Which is x plus y. Is the absolute value of x plus y equals to the absolute value of x minus y? No. So what we conclude from here, it is not. It is not symmetric. Now, what about now the y-axis? The y-axis. What we will do? We will replace x by negative x. So it becomes what? Negative x all squared equals to the absolute value of negative x minus y. The absolute value of negative, the square root of negative x is x squared. And here we have what?
Negative 1 times x plus y.
The absolute value of negative x plus y. Is that right? We take negative 1 as a common factor.
Yes.
This is x squared equals to the absolute value of x plus y. Is that right?
No.
The absolute value of negative a is equals to the absolute value of a. True or false?
True.
So what is a in our case? Is this? Other in other words, take negative or distribute. You know also, Shabab, that the absolute value of a times b is the absolute value of a times the absolute value of. So you can think about this like the absolute value of negative 1 multiplied by the absolute value of x plus y, which of course will be the absolute value of negative 1 is 1 multiplied by the absolute value of x plus y. You can think about it in different. So is it the same as the original equation?
No.
So it is not. What we conclude about the origin? Nothing. It might be not. So what we need to do, let me use here, just mention here what we did. We used here the fact that the absolute value of negative a, it is equals to the absolute value of a. And let me write it here because I need the space. Excellent. Now let's go to the last kind of symmetry. What is it? The origin. Why it will be symmetric with respect to the origin? Now we will replace what? X and y, both of them at the same time by negative x and negative y. So what we will get, negative x all squared equals to the absolute value of negative x negative negative y minus negative y. This will be x squared equals to negative x plus y. Is it equivalent to the original equation? How? This is in fact y minus x. Is that right? Y negative x plus y. It is just y minus x. And this is also the same as the absolute value of x minus y. Is that right?
Yes.
You know that, ya shabab, the absolute value of b minus a is the same as the absolute value of a minus b. So it is equivalent to the original equation. So it is symmetric with respect to the origin. Let's go to the second part, b. What about b? Let's start with the x-axis. What we will do? We will replace y by negative y. So it will be what? X multiplied by negative y plus the absolute value of x multiplied by negative y to the power 3 equals to 1. What is this? This is the negative. You know that this is negative xy. Is that right? Plus the absolute value of x. This is what? I did a mistake here, by the way. When you substitute, you should write it in the right way. This is negative y all to the power 3. Negative y, when you multiply by itself 3 times, it will be negative y to the power 3. I did one step in previously. Now, the absolute value of negative a is the absolute value of a. So this is what? The absolute value of xy. Plus this negative multiplied by this positive, it will be minus negative xy to the power 3 equals to 1. Is it equivalent to the original one? No. Even if you multiply both sides by negative 1, it will not be. So this is not. Now let's see the y-axis. To the y-axis, what we will see? Replace what? X by negative x. What you will get? Negative x multiplied by y plus the absolute value of negative x y to the power 3 equals to 1. So what is this? The absolute value of xy plus the absolute value of x. Y to the power 3 equals to 1. So what? It is symmetric. What we conclude about the origin?
The origin is not.
Why?
Because either one.
Yeah. Take it or leave it. So because if it is symmetric about the origin, it will be symmetric about the x-axis, and this is not the case. It is not symmetric about the x-axis, symmetric about the y-axis. That's it. It will not be symmetric about the origin. Let's take the last one. Did you solve it, Shabab? Let's see. Is it symmetric with respect to the x-axis? How to know? Replace y by negative y. Let's see. Let's do that. X equals to negative 2 multiplied by negative y over x multiplied by negative y plus the cubic root of negative y. Is it clear?
Yes.
This is equals to what? Negative times negative is positive, 2y over negative xy minus cubic root of y. Is that right? The cubic root of negative y equals to negative cubic root of y. Is it right? Is it correct?
Yes.
Why?
Because we distribute.
What is this? This is in fact the cubic root of negative 1 multiplied by y. We can distribute the radicals over the product.
Yes.
And the cubic root of negative 1 is what? Negative 1 multiplied by the cubic root of y, which is negative cubic root of y. So it is. And the negative by positive will be negative. Now, is it equivalent to the original equation?
No. No. Even if we multiply by
Let's see. Negative xy, negative cubic root of y. This is what we have. Let me erase this part. This is what we have. You know, Shabab, that a over negative b is the same as negative a over b or not?
Yes.
So let's take negative in the denominator as a common factor. So it will be xy plus the cubic root of y. Now the negative in the denominator can be written in the numerator or in the front of the fraction. So this is equivalent to what? Negative 2y over xy plus cubic root of y. So it is equivalent. So it is symmetric with respect to what? To the x-axis. And this is the answer. Now let's see about the y-axis. Why it is not symmetric about the y-axis? This is the last part. X by negative it will be negative x equals to negative 2y over negative x multiplied by y. It is negative. What is that? Reconnect. So it will be negative x equals to negative 2y over negative xy plus cubic root of y. Now we have let's multiply both sides by negative 1. What you will have? X equals to what? 2y over. Now this is the negative of the number, ya shabab, the negative of the fraction. Look, this is the fraction. Now it will be what? Negative. This is a term, not a factor. So the negative will stay there. You can write it cubic root of y minus xy. Now, is it equivalent to the original one? It is not. So what we conclude about the last symmetry, the last type of symmetry?
The origin is not.
Why it is not?
Because we don't have xy symmetric.
Yes, if it is symmetric with respect to the origin, then it will be symmetric for all, because it is symmetric for the x-axis, and it is not with respect to the y-axis, so it will not be for symmetric with respect to the origin. Excellent. This is the summary of this section. We are done with 1.2. We will practice next class, inshallah, by solving some